In this video, we'll learn how to find the domain of this given function. First, let's review the definition of the domain of a real-valued function. The domain of a real-valued function f is the set of all real number inputs x for which the corresponding output f of x is also a real number. We'll now apply this definition to the given function. A real number x should be included in the domain of f if f of that real number, or in other words, this expression evaluated at that real number, is defined. When we put in a real number into this expression, we can see that the numerator, which is a polynomial expression, will be a real number. And so we don't face any issues with the numerator part. In contrast, the denominator will not be a real number for certain values of x, and those values of x cannot be included in the domain of the function. Take a look at this denominator. Since square root of a negative number is not a real number, and since division by 0 is undefined, a real number x can be put into this expression only if 2x minus 5 is greater than 0. So we may summarize this discussion as follows. By definition, the domain of the given function is the set of all real numbers for which 2x minus 5 is greater than 0. This is a very easy inequalities to solve, and this is how we proceed. We rewrite 2x minus 5 greater than 0. Adding 5 to both sides, we get 2x greater than 5. Dividing both sides by the positive number 2, we get x greater than 5 over 2. We can now write the domain in set notation like this, and here's the interval on the number line. In interval notation, here's the domain. Notice how we use left parentheses since 5 over 2 is not in the domain and it corresponds to the empty circle at 5 over 2 in the number line graph. As always, when infinity symbol is on the right, we end with a right parenthesis. That's it for today. Thank you.